In the last example, we looked at graphing cosine of x to determine the slope field, which is off the function y equals sine of x plus c. However, sometimes you can't use a calculator, so we need to know how to do this by hand. We need to be able to identify the different slope fields of different functions and match them to equations. So it is possible to produce a family of curves, like in example 5, without actually solving the differential equation. In example 7, we're going to construct a slope field for dy over dx equals cosine of x. So remember that this is just y prime equals cosine of x. This means that the derivative is given by the function cosine. So what you want to do, well, first step, you're going to label your axes. We won't do all of them, we'll just do some. But on a test question, you're going to be asked to identify the slope field or match it to a specific function. So it's pi over 2, pi, 3 pi over 2, and 2 pi. So the way this works is we have y prime is equal to cosine of x. Now remember what y prime is. That's the derivative, which means that's the rate of change at that point. So first let's look at the point 0, 0. So y prime is equal to cosine of 0. This comes from the x value of the coordinate. So y prime is equal to 1. So this means that the tangent line at this point at 0, 0 is 1. So I'm going to draw just a portion of the line with slope 1 that goes to the point 0, 0. Now let's look at the point 0, 1, where this is x and this is y. So y prime equals cosine of 0. Notice that there's nowhere to plug in 1. If there was like plus y, then you have to put plus 1. So y prime again is 1. So through the point 0, 1, we have a slope of 1. Following this pattern, notice that whenever we have x equals 0, we get a slope of 1. Now let's look at pi over 2. So y prime is equal to cosine of x. At the point, let's look at pi over 2, 0, and pi over 2, 1. Well, y prime is equal to cosine of pi over 2, and we get y prime is 0. Using this one, I get y prime equals cosine of pi over 2, so I get y prime is equal to 0. So it looks like whenever I have the x value of pi over 2, I'm going to get a slope of 0. And we're going to follow this pattern by using these x values. So cosine of pi is negative 1. So I'm going to have a slope of negative 1. Cosine of 3 pi over 2 is 0 again. So I get the zeros. And cosine of 2 pi is 1. So I'm going to have slope of 1. And if you reverse that, cosine of negative pi over 2 is going to also be 0. Cosine of negative pi is going to be negative 1. Cosine of negative 3 pi over 2 is also 0. Again, what I'm doing is I'm taking the x value and plugging it into my function. If there was a y value in my function, I would also need to plug in the y value. Cosine of 2 pi is 1, so I get a slope of 1. And there's my slope field. If you compare that to what you had in the last problem, you'll notice it's the same. Also, if we were to follow this curve and make a graph, you'll notice that this line right here, if I follow this out, this is the graph of y equals sine of x plus c. Right, here's another one. If I follow this one, you'll notice how it resembles sine of x. And that's how you construct a slope field by hand.